Hello. So my name is Boguslaw Cyganek. I came from Poland, from University of Krakow. And mostly what I'm doing is research in computer vision. Now we have this revolution of ML/AI, but I'm also teaching. And I am with C++ for over 25 years. And I'm teaching also C++ for over 20 years. So I would like to share with you some thoughts about teaching modern C++. So the question is it a job or a mission? So here is the plan. We start with first things. So know your students, class organization, time, planning, teaching, but most of all, motivation. Then we'll go, overview of some teaching scenarios. So I will talk about intro to programming, teaching materials, and this 2080 paradigm. So I will show you some teaching scenarios with some simple code, and we can discuss this. What is your approach in your classes if you teach? So then we go into object-oriented advanced concepts, things like this. And the question is, can we teach swimming without going into the water? So, well, actually, I'm a scuba diver as well, so I'm teaching swimming. So this is why this comparison to water. But actually, the question is about good examples. So for me, water are good examples in teaching tech subjects. So, and also code refinement and teacher supervision. So these are important. And we'll ask the question, how to deal with legacy code, a programmer's life, how it is like, employers' expectations. So we are not in a vacuum teaching students, so that's the point. And then we'll go to some hints, tips, and helps and also some ESOL study groups, I will tell you. And then teaching materials, and certainly ChatGPT is #1 today, so we'll talk about this teacher maybe as well. So first thing, why I was brave enough to propose this talk and get accepted. If there are many brilliant talks like this by Bjarne Stroustrup, 2017 CPPCon, there is this nice talk, Stop Teaching C by Kate Gregory, and also by Christopher Di Bella. So you can watch all these teaching recipes, and then you can compare also with my recipes. So what I'm trying to do here is just to take the common point of all these approaches and discuss a little bit with them. And now, what I do and whom I teach, actually, therefore, I would like to share with you, because I think we have big experience at our university. Sometimes we compare our university to a small city. It is something like almost 20,000 students, and majority of them are tech-oriented. So what we teach in this Informatica, beautiful building, and this is computer science, certainly. We have actually 5 computer science sections in my university at different faculties. But in majority of them, we teach computer structures, algorithms, but also computer languages like Python, Java, C++, C, C#, and assembly back years. So this is about myself. So I'm just doing research, but I'm also a programmer for years. So I joined these 2 domains, and recently I moved, last 10, 12 years, I moved my teaching materials from older C++ versions to newer versions. I would like to share this with you as well. Okay, first things first, motivation. Yeah, so I was motivated to propose this talk and being accepted. You are motivated to come here, so probably you are involved in some form of teaching. C++, we can say, is probably the most powerful and versatile language used today. However, this makes it difficult to learn and also to teach. So learning can be compared to some takeoff and can be very stressful experience, like a steep takeoff. Yeah. So for example, especially first lessons can be difficult, not only when learning C++, but what I would like to stress here, this first contact with your students, the first lessons are the most important ones. The way you start, it will go this way further on. So this is our duty to lead our students through this process in the best way. And by the way, regarding motivation, the question is how much C++ code is in all these Maverick toys. But if we are talking about motivation, this can be a motivation as well, looking for what is really important in contemporary IT, I would say, or society. So we see that Python is getting #1 for years. That's fine, but this is quite different language. And as I will mention, the best what we obtain in our project is just a combination of both, using some binders. But if you look at this, C is still on second place, but C++ was fourth, and now is third. So we have this increase. And actually, this is what we cover in our classes at my department. This is what we teach. There are some faculties with C#, Java a little bit, but this is what I am teaching as well. But the question is not what I am teaching, but in this context, in what order. So our first motivation is to teach modern C++, then move to other languages if necessary. Also, if you look at this IEEE Spectrum rankings, these are taken from 9 metrics. You can read how they compute this. This is normalized. The #1 is normalized to 1 Python. But if you take a look at C and C++, together, they are also almost summing up to 1. So these are quite useful things. And however, if what I read is quite interesting, the black horse of this, let's say, if you are looking for a job, is just, apart from learning, for example, C++ and Python, try to learn SQL. Then you will have better chances to get accepted to some good companies. So this is what they state in IEEE Spectrum. Quite interesting. But regardless of whatever we do, we are all teachers at some point. So, or likely to become teachers. Even if we start as juniors today, in a year or 3, we will have our younger colleagues, and we'll teach them because there is a project, they need to integrate into this project and so on. They need to help. So I think this lecture can be helpful for everybody, this talk. So that's my mission today. So we'll see if I can share with you something, or maybe you can take some ideas from this talk. So first things first, organization. Yeah. So the key points to ask yourself: know your students. Yeah? Place the goals. What do we want to achieve? Ask yourself: is teaching C++ different than teaching math, for example? Organize the class, organize the time, and prepare good teaching material. So regarding the students, what's their background? Because how we teach depends on who are our learners. Are these absolute beginners or students of electrical engineering with some background in electronics, or they have some background in math or Python, or do they know computer science, at least some other language, or they're just newbies to this area? Maybe I have classes with people like this. They are professionals, they're writing incredibly reliable software, but they prefer to stick to older versions because they are comfortable. But they know they can gain, so for some reason they are coming to us and asking if they can use something, for example, coroutines or other new libraries like ranges in their work. Okay. And or maybe kids. Sometimes we have kids. So the question is, if we start with C++ or maybe Python and then something, the question is why they wish to get in C++ sometimes because it is beautiful. Yeah, that can be motivation as well. Well organize the classes. And I put this image for purpose. Actually, we forgot about Blackboard. Probably many of you remember Blackboards. I remember Chalk and Blackboard and whiteboards. Something. Okay. So when you show the code to your students, sometimes it is better to take a pen and write it by hand. Because if you show something, something is popping up, or even if you do live programming, that's fine for professionals. Because they can remake it at home or at work. But with someone who is just learning how you organize your mind when writing, for example, the main function, it is not linear process usually. It is just making a structure, making the braces, putting some comments. Yeah? If you work with Copilot, for example, this is the way. You put some comments and the Copilot is filling this up. We'll come to this later. So have a plan, but react on students' progress and expectations. We'll be talking about this as well. Be agile. We know this from project development, yes? So how are your teaching colleagues? You are not in a vacuum as well. What's their attitude and experiences? So for example, I have lectures, but two of my colleagues, they have laboratories with C++. So it's supposed to be coherent and concise what we are doing. And not, okay, I'm just criticizing using bare new and delete, and I am using new and delete. So students are just in two different realms. So how to plan our time? I like this image, so you can find it. It's very important. How much time do we have today for this lecture? Yeah, I have to control the time. Or for teaching, 1 week, or a semester, or 3 semesters. So how to organize the classes and the classwork? Well, what about the teamwork? It is better to separate students, so each person is writing code by themselves, separately, or just make teams of 2, 3, 4 people cooperating. That depends, and probably from the very beginning, it is better just to take care of each person individually. Then you can create some teams. Teaching materials, websites, books, maybe ChatGPT. We'll talk about it later. Yeah? So there are many books, but please remember, if you propose one book, then there will be no time for the other, probably. So the choice of primary materials is very important. Overview of some teaching scenarios. Let's go to some code sooner or later, but let's try to propose some methodology. How we can prepare teaching scenarios, not only for teaching C++, but other subjects in computer science, in electrical engineering, whatever. And there is this concept of 2080 paradigm, which is quite useful. So whatever level we choose, teaching basics, object-oriented programming, or advanced concepts, well, we need to ask ourselves, what to start from at each level? What tools propose? Install GCC or use web compiler? What are the consequences? How to present C++ concepts? And I don't mean C++ 20 concepts, just general ideas. Yeah? Prefer a presentation or live coding? Or, as I mentioned, maybe whiteboard or blackboard. But before, let us consider a very useful methodology, this 2080. So that's it. Probably you heard of this, and you may think, well, it's some nonsense. Maybe people are just trying to devise some ideas. But it appears that it is quite useful when you are dealing with not precise information. We all live in some kind of vague or fuzzy logic world. So sometimes we need to take decisions, but we don't know all the premises. So this rule, devised more than 100 years ago by Pareto, called law of vital few, states that in many life situations, 20% of causes is responsible for roughly 80% of consequences. So he observes that 80% of land in Italy was owned by only 20% of population. 20% of workers contributed to 80% of results, so just focus on this 20%. We reward them. And, but going into computer science, some people say 20% of bugs contribute to 80% of crashes. So we are limited in time. So instead of dealing with the whole universe, just concentrate on this 20% of bugs if you need to deliver the product to your client. 80% of CPU time will be spent in 20% of the code, and so on. Just 20% of features. So the key observation is that most things in life are not evenly distributed. So some contribute more than the others. So we are looking for this point. So in our preparation of teaching materials, we'll try to find this golden 20% that can fill up 80% of functionality of our students, what they need at that time, at that level. So that's one of the ideas. So focus on the important 20%. Whatever level you consider, just okay, make a list and then concentrate on 20% of items on this list. Show some concepts, get general directions, and then work out the details. Yeah? What features are most important and appropriate attention. Then move on to the more advanced material and try again to distill this 20%. So once we prepare something, we finish a stage of teaching, then we can adjust another 20% and another 20%. Well, as I mentioned, it is not a brilliant discovery for everything, but if we are dealing with such soft matter, like dealing with people or just having some fuzzy information, we can take this rule. It was checked in many live applications. So also for preparing some classes. Okay. So let's start with some teaching scenarios. So let's assume you have 1, 2, 3 semesters of C++ classes. In our case, at my university, I have one lecture for a group. This is 1.5 hours. And then we have a lab the same time. So for example, like this. And we have 1, 2, or 3 semesters for a course of C++. Certainly we will start with some beginners or absolute beginners. So define the main goals. Yeah? So define the minimal set of C++ features, as I mentioned, for the student. Remember this 2080 possibility. Define the list of optional features, because you will be agile. So if you go fast, have something just in backup. But sometimes you need to retract and go to the beginning again. Yeah? So this is kind of a spiral model. I will show you again in a moment. So I would say keep things simple, but this is not, I stole this from Björn Straustrup lecture. He mentioned keep things simple. C++ is complicated enough, but I would say keep things simple and in proper order. So that's maybe a more precise rule. But be agile also when teaching. We know this paradigm of conducting projects, IT projects, Agile, Scrum, all these things, they show up, be good in practice, but we can also be agile in. So let's keep these ideas just in mind when we are doing. So in other words, being agile is not assuming something for strict. You assume something, but then you react You see your class, how they respond to what you are doing, how fast they make a progress, or they do progress or don't. Okay. So we are at the point of teaching scenarios for absolute beginners. Well, maybe start with such a thing. Just make them know what is a computer before we start making software. I'm fortunate to teach students of electrical engineers, so they have special classes on each device from this picture, starting from assembly a little bit these days, but they know. But I have also classes with other groups. So for them, a computer and processor with graphic cards is just a universe of something. It is always better to know what's behind. So we can start with this. And just, well, it will take maybe half an hour to explain. It's not that difficult. Everybody has kind of a computer. Then go to this. This is API of C++. What is the minimum hardware to run a C or C++ program? Just a processor, just a core with few. The core I started with 30 few years ago was with 3 registers and memory. Now we have all this hierarchy of memories. It is also good to know, because if we say, okay, prefer vector over list, so if we say this ex cathedra is just, okay, someone said this, but explain, give the motivation. So just explaining in terms of memory access is such an explanation. Yeah, but also explain I would say, I call this software development ecosystem. So what we are doing, and also if they used to use other languages like Python, because this path is different for the common things and not common things. For example, debugging is in every language, but not every language is compiled and linked the way C++ is. Explain software development steps, like this. What is requirement specification, problem analysis, implementation, testing, and so on. By the way, you can include also some more knowledge. Why not to teach about some thinking of computer science, like unified modeling language? And this is not just how to express the algorithm, how to draw the algorithm. This is how to think. And what we draw is just a reflection of this thing, it's just a result. But for example, use case scenarios. So on the way of teaching C++, we can teach much more, giving good examples. And just for very beginners, we started with something like this just to show you some code. I know this is terribly simple here, but this is our absolute minimum. So this is for my first class, if I see people just. But amazingly, this, I would say, boilerplate or a template of main and couple of instructions, then with for loop and vector, can be amazingly robust if people get good grasp on them. Yeah? So in other words, they can make a lot of good things just with this simple stuff. But explain, for example, going with the definition of what is an object. Double, it has a name, it has initial value, but this is not the stop. It has some meaning. So express this meaning in a comment. Start with comments, self-documenting code from the beginning. Then show some web compilers or IDEs, whatever fits you. We are using Microsoft Visual because it is easier, but because these are electronic students, so we also require they can remake everything what they do on Windows, on Linux, also in terminal Windows, in terminals, so they are versatile. And the minimum. So what is our minimum? Main function include using directive, std_cout, in double, no more. It is sufficient for beginning. Std_scene for keyboard. Conditional if, vector, string, for, range for, useful. And that's all. So some examples. compound interest calculator, counting occurrences of characters in a text. So I have, for example, like how to make such a histogram. This is a very good example for beginners. We checked that. So people can, the idea is you can teach a lot of things in the shortest possible software, the shortest possible way. So here is the idea, well, very simple string. If we don't have the input from the keyboard because we are in the web compiler, then we can just introduce the string like this. Then we have one loop, stud is alpha. Then we build a histogram, and at the same time we are showing how to deal with other data structure. So vector is not only just a vector of elements, but it can be also a histogram. And histogram is just an estimate of probability. So we are just joining this domain. So we are at each stage we try to teach more. We show also how to write the code, but then let them choose the right way of writing code later on. Here is another loop. Well, just printing the histogram, just simple things. So I will not concentrate on this. Then we go to updated teaching model. So again, we think of this 2080. Remember that we are based on already made lessons, classes. So we have this. We are on the shoulders of the giants somehow. But then, when we teach more, we'll enter into kind of a spiral. So this is very similar to this spiral development model for software projects, for IT projects. So spiral by BEM is just is a development process which is characterized by these repeatedly iterations of a set of elemental processes and managing the risk. So if we transcribe this into, well, here's another spiral, into the teaching activity, not making software, but at the same time, well, we have the same methodology, but now undertaking to the process of teaching, repeatedly iterate a set of teaching processes, increasing level of details. So this is what we are doing. What about risk management? So I would say risk management is when we decide what not to show. This is the tough part when preparing materials. We have so many things, but which is the most important? Where is this 20%? So this is the risk. Maybe because I don't wish my students to have some holes in knowledge after my courses, but I cannot show them everything. Yeah? So that's the point. Okay. So we are here teaching basics. So what we go further with our list is more data types, code debugging, members of stud vector, a matrix, example, vector of vectors, string, auto, common standard algorithms. This is what we are teaching at this level. Structures, struct, references, statements, functions certainly, and struct versus class, but only with constructor, basics of software testing, operators. But also tuples, if we have more time, structure binding. Remember, be agile. So intro to random numbers, pointers at some point, because we have electronic students, so at some point we need to introduce pointers because they need to run some software, connect to some libraries. I will be mentioning this. And some tools, CMake. Stud array at this point, it can be earlier, that depends. It is flexible list. But anyway, know your students and their backgrounds. So maybe they wish to make game development, so you'll go a little bit different way. Even if we go further to object-oriented and software design, so again, 2080 rule. So consider what is the most important, present some concept of design, testing, code refactoring, tools, teamwork at this point, Scrum, for example, at this point. So another list, intro to OP, anatomy of a class, write references, classes with all special functions, move semantics at this level, templates, and generic programming, they already use templates using vector, but now they can write their own templates. Virtual mechanism, at this point, some patterns. These are the most important design patterns, in my opinion, to teach beginners: wrapper, bridge, proxy, memory management, RAI, what is RAI, unique pointer, shared pointer, we can introduce. And on shoulders of this, what are the more advanced concepts? What is important? Where to go from if we make this, let's say, second semester? So again, the minimal list is class hierarchy, file systems, forward universal references, regular expressions, graphical user interfaces with some libraries, clock, chrono, functional programming, stud ranges is good at this point. And for example, expression parsing, interpreter are more design patterns. The visitor, composite is good at this point. More data structures like trees. State machine pattern, very useful for electrical engineers. Yeah? If they make FPGAs, for example, state machine is a basic data structure. And basics of parallel programming. And OK, we teach std_par, the simplest sort std_par, but also how to use std_thread. But we concentrate on tasks rather than on threads. Therefore, we prefer teaching at the beginning OpenMP, then go into lower level API. Well, there are a lot of good examples. And the swimming. So what are good examples? This is the most difficult thing, actually, even more difficult than preparing the list to teach. Comprehensible, certainly, not too long. You cannot present an example for 10 screens, so everybody will be lost. And touch on real problems. That's the key thing. And can be extended into more advanced versions. So the good examples are this, which can be in the spiral model. They can be continued by students. Once they get more knowledge, for example, on vector, on other data structures, stud maps, etc., they can continue the same. For example, simple database, they can make it with a graphical user interface and so on. So we don't jump from a project to project. We just refine them, actually. And how a student can use an example. Just compile it, make it run, debug, that one way, retype and example and make it run, because you see the code. Just don't Control-C, Control-V and copy-paste. Just retype. It takes time, but you will think as a student how to make it. But even better is just remember the idea of the problem in the example, and then try to remake it by yourself. Then you will see what you know or what you doesn't know. Yeah? Use a startup for your own project. So from the projects we present, this can be used for more advanced projects by students. But now some student projects, yeah, so they can make on their own. But what is important? This feedback. They create the project, you give them the node, and that's it. No. You sit down with each student individually, and you do code refinement under the teacher's supervision. And this is like code review, and then okay, give them motivation. Why you propose this or other things. So some examples, quite fast. This is one of my favorite. Still with one main, one loop, you can make such a game quite easily. Then you can make it. In the graphical user interface, whatever. We'll return to this example in a moment. Other examples, matrix is beautiful for examples. Vector of vectors, just for beginners. That's a matrix. It can be embedded into struct, then into class. So, OK, we start with this. Couple of lines, and we have a matrix, a real matrix. We can use it. We can learn how to use vector, how to use using, and so on. But then we go with this idea. OK, we have this real matrix, vector of vectors. but we put it into struct. So we can wrap it up, and this is a wrapper, adapter actually. So we are teaching also how to compose the code. Something has something inside, but this is still structure. Everything is public, and we add a constructor because we wish to constrain from making a matrix of 0 rows and 7 columns, for example. It must be at least 1, 1, or 1, 2, or whatever. But how to check that condition? Okay, there is a comment how to use this class, but we can also teach how to use pre and post conditions. So this is going into programming by contract. How many of you are using programming by contract? Well, I wish I see more. It saved me my life so many times as a programmer, naturally, that it is just like a fuse in electrical circuit. It just fires if something is wrong at the production of your code, of your thinking. Yeah? This is different level of just checking yourself with your assumptions in the code. This is not like if in runtime or throw in runtime. This is just, usually asserts are gone in release version, but this is just to, okay, so we are teaching students this. And we have some helpers. It is much easier now, because you don't need to call this data, fdata, size, something. You just get calls, get rows, and that's it. Then we go with some examples of matrix multiplication. Again, we have a contract, checking some conditions. We show how to build operator overloading a little bit later, so we are in the domain of functions. But we are still, on occasion, we are teaching some algorithms, because people these days, they don't know the algorithms. Many of my students never implemented sort, and they are just amazed with the first version of a sort, whatever it is. But let them do it once in a life, yeah, just from scratch, with loops, with some errors. Then they can call stud_sort, whatever the algorithm there is. Yeah? But here is also how to multiply matrices. Then we go with the same example when we teach parallel programming, because just interchanging these loops affects performance of this. And here is the third step. We just go into object-oriented realm. We have everything private, so data is private. Now we have the same stuff, but we need to add operators, subscript operator, overloaded, begin, end, iterator. So we are explaining iterators, other functions, friends, streaming, things like this. Yeah, well, I will not go into too many details, but you can find this code. You have. I will give you some links to this code, and certainly we all have some examples. More advanced. Well, such a simple thing, for example, just recalculating the currencies. In Poland, we still have zloty, not euro, so we need to recalculate sometimes. It's just simple multiplication. So in a main, just a one line, enter the value, the exchange ratio, and you are done. Well, simple? Yes, for beginners. But then you can go further on. Step 2 would be just think. It's not that simple like this, like multiplication. Well, you can sell, you can buy. The currency rate is changing. How often? I don't know. And so we have this table. And how to implement such a table? Yeah? So we can provide such a data structure, yeah? Step by step. Here we have a map. Then we have another UML class diagram. Remember, we are trying to teach more. We are teaching software design. So we use UML. We have T-currency exchanger. T-currency exchanger can contain T-currencies and so on. Then we go to the code. Yeah? Well, code is, well, for example, using wide strings just to print some international characters is not that easy to make this program working equally on Linux and Windows, for example. That's the challenge sometimes. So here are some simple functions just to show some code. And here is another class with this stud map or an ordered map, whatever. But we see the private, the public. So now the students can write the convert functions in this environment. But what we wish them to have, show the concept of self-documenting code. Because everybody is just skipping comments. For some, it's a waste of time. No, just make the self-documenting code, and if you are using Copilot later on or something, it can generate you some code. Then go with another step for advanced, with the same example, starting from simple multiplication. So show them components, a pattern to download HTTP file in different Linux and Windows environments, and show this sequence diagram. So how many UML diagrams we can make at occasion of some projects. Yeah? And the last step in this development is just add graphical user interface. If your components are separated enough, this will be easy going from terminal window to graphical user interface. Yeah. But we also teach, if we have more time, make it in Python, make it web-like, and then make pbinds 11 or something binders and call your C++ engine. Okay, just some example. So code refinements, remember what I mentioned, this is very important. Students do something, then don't stop. Go with them and show your opinion. So you do code refinement, very important process. Example of students' pattern, well, like this. This is from students' code. Everything public. I'm asking why, because it's faster. Yeah. No initialization. Why? To speed up computations. Yeah. So these are answers of my students. That's fine. What about this? Yeah. Well, some card play game. Vector of pointers, I'm asking why? Because card reference didn't compile. Well, should it? I don't know. I asked not to use new. This is what I'm saying. Yeah, but I found this on the internet. And it compiles. That's the argument. What about this? Vector of pointers. Why? Because card reference didn't compile. And this did. Indeed. This is what a student had. So how he or she can explain what was going on? Some X memory error, pointer to reference is illegal, compiler is not helping. Maybe the next generation of compilers with AI inside will explain what's going on. This is what we are working on as well as scientists, but this is not helping. So this is not a surprise for me, why the student tried to find a way. And he did, but with many errors. Yeah? And another way was, it was not the idea of the student, so he was very surprised that it can be that simple. Like vector of ints, it can be vector of cards. Yeah? So this code review, actually, teacher and student, is also like pair programming and code review methodologies. So, well, we can build our teaching processes on some good processes from software development, which are checked in practice. Yeah. So, and this is mentoring. But the world didn't start today. Legacy code, programmer's life, employer's expectations. So how to prepare students for the legacy code? What is a programming life like? Tell me about it. Can we address employers' expectations? Some, maybe, they're coming to us and they say, okay, you should teach this and this because this is library we are using in our code base. And we are saying, but we are not using this, we are using other things. So is teaching C that bad? Maybe not. The question is at what point? So, yeah. Teach modern C++, but remember of a more complex environment. This is sometimes skipped by the academia, okay, by the teachers, that the environment is really complicated with all these tons of legacy code. Yeah? So even to use OpenMP, OpenCV, GL, we need pointers, we need some unions, or even a simple int main with all these double pointers here. For students can be intimidated. What's that? Yeah? So at some point we need to grasp this, to go into this. Yeah. They will find some legacy code. Yeah? How to deal with old code? Refactor or just, I don't know, but we can teach some techniques. This wrapping up is one of the ways. Yeah. So when we are teaching C++, we need to introduce this lower level constructions at some point. So this is up to us at what point and what constructions. So I remember my first job in programming, 25 years or something, terrible. But I was doing just translating 68,000 assembly into C, because one company, they had a really big editor on Apples, and they were in deep problems when Apple changed from 68,000 to PowerPC processors. So it couldn't be done automatically, so I remember this. So this is when I learned how to make old code run or make refactoring to C++, or sometimes we had to cut up the old part and remade it. Yeah? And also some hints, tips. Let's go fast through this. Yeah, what I would like to mention is learn when teaching. So we are just teaching and learning ourselves. But in this spectrum, what I would like to mention is this SG20 group. So everybody of you can help us. I'm in this study group 20, and our purpose is to prepare this proposal for study group. J.C. Winkel, Christopher DiBella, a couple of guys. We were split into a couple of subgroups, and we cooperate. And what we are doing is just building this preparing context and aim of the guide. It is not a textbook. It is just a guide if someone prepares a textbook or just provide guidelines for content to be covered by courses. I will not go into details, but if you wish to join us, I am in this group. I think it is useful. Teaching materials, fast. Reference, fine. But it can be intimidating for beginners. It's everything. Stack Overflow, very good. Primary source of any information in programming, but also troubles. Yeah? Remember, some posts can be old. Core guidelines, brilliant. But to improve, if you know what you wish to improve. Books, very good book. A little bit outdated. Very good book. This is quite new version of Bjorn Straus's book, but maybe not for beginners. It's just for someone already programming in C++, but trying to get into modern C++. What other books? I like this too, but I wrote this one. So if you are interested in just a textbook with these 3 steps of semester 1, 2, 3, you can get the code for this. 1 semester, 2nd semester, 3rd semester, and some on computer arithmetic and power programming as well. And in an appendix, preprocessor, basics of C, CMake, Git, such a tools explained in appendix. But here is the game changer. Large language models. Yes. So what about this? We have also this Copilot. You can use it. Yeah. So here is my experience with ChatGPT. So let's start with some examples. Can you show me how to write a simple example in C++? Well, that's it. In a few seconds. Cout, hello world, and also it is explained what is hash include, what is int main, things like this, even how to compile this with something. What is this? G++. Okay, if I know what, I will do this, but maybe I don't. But anyway, I can ask what is G++ and so on and so on. Probably if I know what to ask, I will give the proper answer. But what about, can we implement a simple terminal-based game? Yeah, because I know for, main, so I am a student. That's it. Yeah? In a moment, few seconds. Yeah? That's the the second part, yeah? And also explain, what about this secret chamber? That's the challenge, okay? Well, this is what I wrote, and after 10 my iterations, 10 minutes, I got this. Well, not the way I wish it, but it works. It doesn't crash. But if I were a student, well, can I submit this as my project? Or even if we program in the companies, I'm sure it is copyright free. And the second, maybe more important, is it correct? Yes? So maybe not. Well, I wrote a question in Polish language. That's napisz mi ostatnie pytanie i twoją odpowiedź po angielsku. Well, that's also a very good thing. Remember, this is large language model, so it understands languages, our languages and computer language. So it can be useful. Well, why do we use rand function? My teacher says it is outdated and that we should use it. Well, and he said that the teacher is right. We should use std_random and so on with examples. I'm glad. Well, so I have not too many minutes left, but let's go to some. Well, we can talk about ChatGPT for an hour or more, but it is a real revolution. It's not only a tool. We are just, well, 10 years ago I published a book on computer vision methods, machine learning, and it is outdated. Good stuff, some tensors, mathematics, principal component analysis. With MLAI, I had to change totally my laboratory, my thinking. So this is also going into programming in some way. I don't know what way, but some says they don't need junior programmers. Yeah? So boss is happy. I will fire you all. Yeah? But the question is, if we are talking about teaching, so maybe they need senior programmers, but can you be a senior not being a junior before that? Well, so ChatGPT, in my opinion, will not replace a good teacher, yeah, with a good lesson plan. Yeah? So it should be treated as a tool. Like, well, maybe like older colleague who knows better, but certainly, so can be a supporting tool. But the key for students is to understand the code and to be able to control, and all of us, what ChatGPT is proposing, actually. The problem occurs when someone, instead of programming, doing the stuff himself or herself, takes shortcuts, yeah, and uses ChatGPT and only copies the solution. Yeah. So we need to be sure that we are not just making students to learn only how to make prompts and copy try without understanding what's going on. This is very, very important. So we are allowed to use this, but this is the first what we are telling them, how to use it. Yeah? So now we are at the point of general conclusions for my talk. So I'm almost finished. So the quality of software of the future depends on the quality of education today. So it is true and probably will be true in 10 years. So that's probably important. And we all are students, and many of us are or become teachers on many occasions, not only at academia, but in many situations. So the thing is, know your students, their needs and wishes, well organize the classes, give motivation. At work, also. These are all your students in your team. Think of choosing the right features to teach with this maybe 2080 rule, maybe it is useful for you, maybe not. Well, I'm using it to some extent, therefore I present it. Provide good and practical examples. So to have good examples, think of them ahead of your classes. When you program something and you find something beautiful, C++ is beautiful, yeah? So if you find something nice and interesting, just copy it. Okay, just copy it for a potential example, then prepare for teaching. This is the good way. Keep things simple and in the right order. Be agile, not in software projects, but also when teaching. Teach in a repeated manner, increasing the level and details. Remember about the spiral model. It pays off. Teach not only C++, but C++ in the computer science framework. So this is software design, UML, data structure, algorithms. We can do this to some extent. Don't forget about the programmer's company's reality. So show how to connect to some libraries. It is like legacy code. And ChatGPT is a great support tool, but it will not replace a good teacher with a good lesson plan. At least not yet. Keep on self-training also. Always increase skills of your team. Watch, attend lectures. So this is what we are doing. And last thing, I ask a question in my title. Is it a job or a mission? Sometimes it is a job. But best for the students is if they meet someone passionate about C++, like we all are. Thank you very much. Some questions, maybe?
Yeah, thank you very much for the talk. You touched on some of the methodologies of approaching writing code. You touched on UML, for example, or understanding the domain around the problem you're actually trying to solve. But once the conception has been done, once the code has been written, there's also the validation phase, usually in software engineering. What's your experience with teaching things like test-driven development or going into testing frameworks and stuff like this? So how do you actually write not just elegant code, but actually functional, correct code?
Yeah, very, very good question, yeah. We start from the beginning by step. So the first thing is debugger is your friend. So this is first thing. And then we, at some point, and in the, well, not very basic level, but when people can write something, append some libraries, make a project, we use some platform. Actually, for my classes, I prefer GTest, just to concentrate on something. But at the same time, I'm telling students that there are many other platforms you can, if you wish, you can use another one. And we also present all this. It was on the beginning with this UML diagram, activity diagram. All the steps of software production are required, even in our classes, but with different focus. So always is this step of problem analysis. Don't write something because we wish to write at the beginning. Just think. Take a sheet of paper and make an example of, even with this matrices example of something. Yeah? Then go to the code, then validation, and so on. But certainly, well, for real stuff like continuous integration, we have different classes about methodologies of projects. This is not we are teaching at C++ classes, but we have lessons on this.
Okay. Do you think it's beneficial to split it up into two different classes, one about a C++ programming and one for testing? Because in my experience, it has been always beneficial to say testing in what form or whatever is an integral part of writing code.
This is what we are saying. If you take a look in my code, this is on the GitHub. You can Google it up with my name. Well, it's probably somewhere here. Yeah, you will find that we add this G-test quite early to the examples, and we require. Then they have home assignments for half of a semester, and I require from them documentation and the tests as well.
Okay, thanks very much.
It goes on together. I have somewhere this list. Oh, here it is. You can. Okay.
Yep. So, do you think we should consider some prerequisites for teaching C++? I mean, you're talking about like learning or teaching from scratch, right? And I would add to this: do you think we should limit this, well, I wouldn't say we limit, we think it's really the optimum way to do it, that we teach that to computer engineering or computer science or computer electrical engineers, or?
Well, this is the question of motivation, why they are here. Yeah, if someone is trying to become an electronic engineer, this is our responsibility to make a plan for these studies. And we decided that, that it is important to teach some programming languages. So, for example, they need to cooperate with operating system, with Linux, make the embedded system, so they need to program. So therefore, we chose C++. Back years, we started with C, then moved to C++. Now it is vice versa. We start with C++, this is very important, to make this mental process modern, then we go to C. This is the way.
Okay, and also about the modern C++, would you say that we should stick to one version?
Well, not too modern, okay? So don't go with coroutines on your first lesson, okay? Well, in this book, I stopped on version 17. I mentioned ranges. It is like with software development. At some point, you need to say, that's finished. Yeah, this is the line.
Yes, yeah.
So that's
and
it.
Do you have a rough figure of the teaching hours, like an estimate?
Teaching hours? As I mentioned, we have different assignments for 1 semester, for 2 semesters, or for 3 semesters. So depending on this assignment, you plan your classes. And usually this takes 1 lecture, this is 1.5 hours, more than today, and this talk, and 1.5 hour lab, and also the project assignment for students, for self-doing this.
Yeah, thank you.
This is like this. At least at our university.
Hello, I've been entrusted with an apprentice a few months ago, and I find it very difficult to explain abstract concepts like design patterns.
Yeah.
Because I think the student doesn't have enough knowledge already to intuitively get that or make a mental map of that. So I've been wondering, how do you go about that?
Very good question, yeah. Well, just provide real examples. So what is the way to remember design patterns? Maybe this is not your experience, but my experience was, when I was reading about design patterns, just to try to remember some real example, when this handle body is useful. So for example, the first pattern is adapter, what I show in this classes. So this is a wrapper. So I'm showing, okay, you can use vector or vectors like a matrix, but this is difficult, this is difficult. But when you wrap it in a struct, it is easier. So this is how to deal with old code. And you go on. Then you show, okay, I can make something like a uniform class, everything is, we call this fat class, everything is one class. Yeah? But if you deal with these HTTP connections with Linux and Windows, so it is good to separate representation from implementation. Well, it pops up, it is a bridge or handle body. Yeah? So just always remember some real examples, then you will remember the design pattern. And don't go too fast, because there is the other way. People learn design patterns, and they are very keen on putting this or the other design pattern into their code, even if it doesn't fit. So this is, just step by step.
Thank you very much.
Thank you for that great talk about that very important topic. Unfortunately, we are out of time now, but for anyone who wants to discuss about that topic, about learning C++, teaching C++ a little more, we got a track tomorrow in the lounge at 10:20. So anyone who's interested to talk about that some more, join us there.
I will be there. Thank you.
Thank you.